I'm not going to repeat myself. Hello, my name is Stefan Wintermeyer. Here it is. If you have questions, ask me after the talk or send me an email, DM me on Twitter or whatever. So I'm going to talk about web performance. What is the impact of a slow website? These numbers here are seconds, and this is the loading time. And you see, you want to be in this area here, between 1 and maximum of 3 seconds, better below 2 seconds. If you are already here at 18 seconds, and you increase your speed by 1 second, you won't see a big difference in bounce rate. You want to be here. That's the aim. Why is that? There are a couple of different studies. These are numbers of one studies where they measured how humans react to feedback from GUIs, machines, whatever. When a human has a feedback from a system between 0 and 100 milliseconds, it feels instant for the human. And everything below 1 second is okay. But once you go above the 1 second, you start to get a mental switch. So the human thinks it's kind of slow. And that's just a human thing. So you want to keep your website, if possible, below 1000 milliseconds. That's kind of the gold standard. Google did an interesting experiment. They slowed down their web page for a specific user group. And they measured how that user group reacted. And you see, this is the impact. So they lost users by making the web page like 200 milliseconds slower, which is kind of nothing. But they could measure the impact. The interesting part is it took some time. So if you have a slow web page and you increase the speed, you won't see a difference the other day. It takes some 6 to 4 weeks to get the impact in your statistics. Always keep that in mind. These are the numbers which are not up to date. How many people are using their mobile phone just as their only device to get in, to browse the web. And that's actually today the numbers are higher. So the aim is you want to be able to deliver a web page within 1 second on a 3G connection, because not everybody has LTE. What does it mean? We have to handle a couple of overhead here. So we have a DNS lookup, we have to establish the TCP connection, the TLS handshake, the actual HTTP request. So at the end of the day, we have about 400 milliseconds to render the HTML on the server. And I'm talking now Ruby on Rails. And we all know Ruby on Rails is kind of slow. So that's not easy, but it's doable. We cannot fix all the web performance problems within Rails. So if you're loading a 3 MB JavaScript file, your web page will never be fast. Some basics about how a web page gets rendered. So first, the browser asks for the HTML file, for example, index.html, gets that file, and then the next thing is it downloads the CSS file. And once it has these files, the HTML file, it starts to render the DOM, and once it has the CSS, it starts to render the CSS DOM. After that, it downloads the JavaScript. Until now, nothing happens on the screen. That's all overhead. At this time, when all three come together, you see first painting on the screen. So there's a lot of stuff going on in the background. This whole process takes a minimum of 100 milliseconds. If you have a slow device or a low memory, etc., it's even worse. So you kind of want to subtract these 100 milliseconds from the 400 you already have. So how does a download or file transfer in HTTP 1 work? HTTP 1 uses TCP, and TCP is the central bottleneck here, because TCP has something called slow start. So it starts with a three-way handshake. And then after you send the GET request from the browser to the server, the get index.html, the server sends you 10 TCP segments, which is about 14 KB. There's no way to improve that. That's TCP protocol. After the browser received it, it says, okay, I got it. And then the server says, okay, that's double that amount. I sent you 20. Same again, I sent you 40. And the bottleneck here is latency. I don't care if you have fiber or LTE or whatever. The bottleneck is latency. So if you have a server somewhere in the US, the web page will never be fast here. You want to have a server which is near your customer. That's the most important lesson you want to take away. So these are the numbers for TCP slow start. And again, these are round trips and latency only. There's no way to improve that. With HTTP 2, you have the same problem with TCP slow start, but you have the advantage of being able to download multiple files at the same time. So you still want to be sure that the first part of the web page doesn't take a lot of payload. But after that, it's getting easier. Therefore, by rule of thumb, if you have HTTP 2, it's about 20% faster than HTTP 1.1. So if you have the chance, always go with HTTP 2. That's an easy win. Here's a tool you can use. It's a free tool, webpagetest.org. I used that to get this waterfall from this web page, because I did the whole slides first time here. And let's have a look. This web page on 3G takes over 5 seconds for anything to happen on the screen. So it's quite slow. And the reason for that is here. So you see, the first file, the index.html, it takes nearly 2 seconds to download. So that's the major bottleneck here. To give you an idea, I have this video. Boom. And still, it takes forever. But let's see how that works with ATE. It's much better. Still kind of slow, but better. So you see, all the JavaScript here, that took forever. So you really want to think twice if you need JavaScript for this kind of fancy stuff here, or if you can get away without. It's always fast on your own machine, but you want to have a fast connection for the users. So to give you an idea how fast you can become, this is my web page, and it starts rendering at 500 milliseconds. And that's because it's really fast with this file here. So to give you an idea, and that's again mobile. I'm not talking about fiber or something, that's mobile. And we all know mobile, most mobile first thing, that's a big thing. So how many are you familiar with Rails? Just to make sure. So, this is the basic application I'm talking about, to give you an idea how much speed you can get with caching. Though this is a ERB, we have categories, we have products, we have users, we have reviews. So a very basic shop system. The products belong to category and have many reviews, and we calculate the number of stars, which is the average of the review. These are the seeds. I'm using the Faker gem to fill up the database, and right now we are creating 100 products and 50 users. This is index.html. Pretty standard. The only difference here is the number, the product price. I'm using number to currency here, and I'm using this part here to actually render the stars. So with a little bit of CSS, the page looks like this. Very simple. So how long does it take to render this page on my laptop? A whopping 497 milliseconds. So we are already way beyond our limit if you want to have a fast web page. And that's a very, very simple web page. That's nothing special here. Very, very simple. So again, we are over our limit. So the first question always is, yeah, but you use development environment. Never do that. That's for the crazy ones. I'll switch to production later, but the numbers are not that much better that you get to the 400 milliseconds. So what you want to do is fragment caching. You can activate caching on development with Rails dev cache, because otherwise it will be not active by default. First step, let's cache the first row. So I'm talking about this row here. Let's cache that. We do that with fragment caching here and here. So this part gets cached. This is our cache key product. That's all done by Rails automatically. You don't have to think about the cache key. So what is important here is that we touch the product whenever we create a review, because otherwise the cache key doesn't get updated. That's very important. So what does that mean? We started with about 500 milliseconds and we are down to 80, just with 2 lines of code. So that's a big win. Second step, the complete table, the Russian doll. So now we are caching everything, and again 2 lines of code. This and this, and that's it. Let's see the numbers. We are down to about 50 milliseconds. 4 lines of code. But let's not stop there. Let's think about our application, and that's very important too. This part here takes forever to compute. And why? You only need to compute it when you change the reviews. So let's add a migration to the system and store that number, the value, in the database. And then use a hook to recalculate it and store it in the product. So whenever you add a review, you change the value in the database, and that's much faster. So now we are down to 35 milliseconds. That's fast. That's really fast and good enough. Obviously, the first request will be slower than before, because you have to write the cache first. If you really need more speed, Phoenix is a very good alternative. So HTTP caching, that's the next step. Web browsers and proxies don't want to fetch the same stuff multiple times. So there was the idea of an e-tag and last modified tag. So the web browser says, okay, my user wants to fetch this and that file, and I have a cached copy. It's a week old. Can I use that? Is that still good? And then the browser says, yeah, go ahead. It's a 3 or 4. It's not modified. So you can use it. And that's a very powerful tool because you don't have to render the page. You don't have to touch the templates. You can do that within the controller. And if you want to see this here, these are the e-tags. And you can check that with curl-i or in your favorite browser. And what you want to do is add this fresh when e-tag, add products for that very same page, for the index page. So that's going to be the key here. And then if you download the same page twice, or you try to download it twice, you get the same e-tag. And you get a not modified for the second time. So that's super powerful. And that's good for you, and it's good for the user. So you save time on the server. You can get away with less CPU power on the server, saving a lot of money. Still not good enough? Writing the initial cache takes a lot of time. So we can preheat the cache. Our servers are running 24/7, but normally our clients are only awake in a specific time of frame. So let's use the night to preheat the cache. Just use brute force. The servers, they're computers, they don't care. So let's do that. The last improvement step is, and that's kind of the gold standard, the fastest page is a page which doesn't get touched by RAIDs at all. And I'm serious. It's not. I'm very serious. So how can we do that? We already have the system for that because we have the public directory. Everything in the public directory doesn't get touched by RAIDs. It gets delivered by the Nginx or Apache or whatever web server you use by itself. So that's the fastest way of delivering anything. So is there an easy way to use that? And yes, there is. It used to be default. Now you have to add the gem. And then you can say caches pages. These are the actions we cache, and you can say, okay, gzip it also. So the web server doesn't even have to gzip the file. And then just brute force as your friend. Go through your whole application. Now the tricky part is, if something changes, you have to delete those static files. But we have active records for that. We can use a hook here. So we can delete the files whenever something changes. And I know this is very extreme, but again, it's super fast and you really save money on the server. So what do you do if you have customized pages? Because those pages cannot be cached, we all know that. False, you can cache them. You have to think a little bit more about that. Let's assume we have a user base of 10 million users. And let's assume that's just an old slide from a RAIDsconf talk. Let's assume that file is 28K. So 28K times 10 million, that's 0.226 terabyte. That's nothing today. Hard drive space is super cheap. So it is easy. You can use that method. And it's super fast, and it's so much cheaper. Nginx will happily use the cookies you're already using to see which files it can deliver from the static files and which one it has to ask RAIDs for. So you get best of two worlds. The setup is pretty complex. It's not for the beginner, but if you really want to speed, that's the way to go. As I said in the beginning, HTTP 2, that's a very, very low-hanging fruit. So if you have the chance to upgrade to HTTP 2, do so. Easy 20% web performance improvement. Next question is always, what about CDNs and HTTP 2? The problem with CDNs is that's an idea for HTTP 1.1. That made sense with 1.1. It doesn't so much with 2.0 now, because with HTTP 2, you already have that pipeline, and it's already widened. So you want to use that same pipeline to deliver everything, and not open another pipeline. That made sense with HTTP 1.1, but not anymore. So if you're using a CDN already, and you are upgrading to HTTP 2, think about moving everything from the CDN to the server. Active storage, because we are talking about 5.2, obviously you should use active storage to deliver the right file format. You have the choice between JPEG, PNG, WebP, GIF, whatever. There are multiple formats. Don't just use one. Use the one which is best for the given browser. And you can use the tools within Rails to do that. The question always is then Apache versus Nginx. I really don't care. It doesn't matter. Use the one you like. I like Nginx. I like Vim too. Never understand how Emacs works. So what about Protly versus gzip? Protly is kind of a new compression tool. And you always want to offer both, because it's, again, an easy win. Normally, you can save about 5 to 10% with Protly. And it takes less CPU power on the server, too. So, no-brainer. Heroku versus bare metal. And Heroku is just an example here. Heroku is good for a quick start. But if you want to have maximum performance, you really want to go bare metal. And it's cheaper, too. So from a speed perspective, you really want to go bare metal. Preloading, prefetching. There are a couple of things you can do within the HTML. So if you already know that something happens in the future, like you want to load a specific file, you can do so. You can do something like a DNS prefetch to make sure that your browser already fetches the DNS records. That saves you like 35 milliseconds. You can prefetch files which you want to use in the future, and they are already in the cache there. So you really want to do that. And you can tell Nginx and Apache 2 to push these files with HTTP 2, because HTTP 2 offers the possibility to push stuff to the browser, which is very powerful. The most important tool, it's a time budget. So you want to set a time budget, and within that time budget, you want to act. If that time budget says, okay, I want to deliver a web page within 5 seconds, that's good. I wouldn't ever do that, but if that's okay for you, go. But then don't break that 5 seconds. If that marketing guy comes to you and says, I want to have that fancy animation, and it breaks your 5-second rule, then that's a no-go for that fancy animation, or you have to get rid of something else. So you have to set that budget and work within that budget. That's the most important thing. So is web performance really so hard? Yes, it is. It is super, super hard. That was just the tip of the iceberg, and just 20 minutes is not enough to cover everything. But luckily, this is kind of the Bible of web performance. There's a free version online, and you really want to have a look into that. And then, by coincidence, I wrote a book. So I brought 3 of them. I can sell 2. If you want them, I said 2. And the third one, I saw alcohol somewhere there. So the one who gives me a drink gets one free. Okay. Here I post updates about web performance and everything, like my kids, etc. This is my email address, and that's pretty much it. Do we have time for questions, or?
Yeah.
Okay.
So how to get a book? First question. How to get
The alcohol is the one question, and the others I have to sell. You can buy them, no problem.
Okay, we have time for questions, guys.
Yeah.
You mentioned broadly algorithm
Sorry.
You mentioned it broadly algorithm. First of all, thank you for the talk.
Yeah.
And
You're welcome.
Again, like maybe 10 or 15 slides ago, you mentioned it broadly algorithm.
Yeah, broadly. Yeah.
Should I take care about browsers which don't support it? And how
No, because you always have to offer both. You always offer broadly and gzip, so you don't care. If a browser doesn't support it, it asks for gzip. The browser tells the web server which compression it understands with a GET request. That's in the header. So it says, okay, I want to get this and that file, and by the way, I understand these compression methods. And if that doesn't say broadly in it, then the server doesn't deliver broadly. But if it does, it delivers broadly. So it's a no-brainer.
Okay. And the rest okay about just generating both. Right?
Yeah, but that does the web server. So that's work of Nginx or Apache. Yeah, Rails doesn't have to care about that. Dima.
Should we care about latency if we set up HTTP2? Since you said
It's
that CDNs no longer
latency is always the bottleneck, always. Doesn't matter if you're using HTTP 1 or 2. Latency is always, you always want to have your server as near to your clients as possible.
Yeah, but with HTTP2, I guess everything will be delivered like one batch, no?
No, it's the same problem.
Then why CDNs may no longer sense if we use HTTP2?
Because then you have to open another connection, which takes time and which doesn't. Then you have two connections which don't use the bandwidth optimal. With one connection, you get the maximum bandwidth.
Yeah. Okay.
I have one more question.
About HTTP2 and CDNs, how about caching? It will still works if we deliver from CDN. The real question I was about to ask is about APIs. A lot of these techniques with meta text won't work with API applications. What do you recommend for an API?
Think about the problem. It's always a good idea, because you can use the same techniques with any API, the very same techniques.
Yeah, about caching, yes.
Again, you can use. I don't care if I deliver an HTML file for a human or a JSON file for a machine. It's the same problem.
No, I'm asking about exactly this meta text. Do you have something?
The prefetch stuff.
Yeah.
No, that doesn't work with API. Yeah. But you could push it. If you're using HTTP2, you could push it. More complicated, but possible. So one last question.
One more thing. Do you use any tool like CI to check, for example, page to load like 1 second, now it loads 1.5 seconds, and it like stops CI and just says, oh, don't merge this PR, it's breaking performance. Do you have a tool that does that?
Yeah. There are tools for that. That's how I make a living. That's very complicated, but possible. Send me an email.
Consulting.
Yeah. But that's possible. Have a look at Ghost Inspector. Maybe they are offering it in a free version. I'm not 100% sure, but
I suppose that was some kind of reverse proxy that simulates bad network conditions.
yeah. But now Ghost Inspector, you can use Ghost Inspector to automate stuff, and you can automate testing with that. But again, it's possible, but complicated. Thank you for having me.
Thank you.
Thank you.